What pops into your head if I say the word Texas or Nile River, maybe India? These are places on Earth that we hope at this point you have got some idea where they're located. Because you've been in school long enough and we've been teaching you a little bit of geography, if we gave you a globe, we hope that you'd be able to maybe locate them in, a reasonable amount of time. The periodic table also has a certain geography to it, and that's what this lesson is about. It's been about 10 years since I made a video like this, and so it probably is due for an update. The periodic table was discovered, noticed, found by a Russian chemistry professor named Dmitry Mendeleev. His name is spelled a couple different ways depending on where you find it. Russia has got a weird alphabet. In the late 1860s, he took the 60 known elements at the time, wrote down their stats on cards, and then started kind of arranging them in ways that showed certain patterns. And as he arranged and rearranged those cards, he found that those patterns got richer and deeper and even more beautiful. He was so sure that his patterns were correct that he left blank spots in his table for elements that he figured we had not discovered yet. And then it turned out within just a few years, 4 of those predictions came true. He predicted what that we were missing and exactly what they were going to be like when we found them. That would be like if I came up with you with a fancy table and I told you who was going to win the Super Bowl, but then also who was going to win the Stanley Cup, and also who was going to win the NBA championship and maybe what the final score was going to be, and then also who was going to win the World Series this year. You would think that either I was Biff with the sports almanac, or this table of mine is somehow connected like deeply to the universe. And that's what the periodic table is. This is not something that humans invented. Mendeleev did not make this thing. He was just the first person to discover something that was existing in the universe all along. The periodic table is arranged into rows that we call periods, and then up and down columns are called groups or families. Elements in the same family have similar properties. This is a picture of my wife and my daughter and my mother-in-law, and you can see that there are family resemblances. Maybe you have this same thing with your family. Elements that live in the same up and down vertical column live in the same family and have similar properties. This is how Dmitry Mendeleev was able to arrange his periodic table just using the patterns, and it ended up being that he was arranging it on electron structure, but this was 30 years before we even knew that electrons existed. The first thing I want to show you, the first feature, the first geography of the periodic table is a thing called the staircase. At least that's what I call it. I'm not sure if it has an official name. It's a zigzag line that goes from boron down and to the right all the way through the table and divides it into 2 parts, similar to the way that the Mississippi River divides the United States, kind of into 2 parts. All of the elements that touch the staircase are called metalloids. All of them except for aluminum. Aluminum is an important exception. Aluminum is a metal. The metalloids, they're ones that we just couldn't figure out. All the other elements are either nonmetals or metals, but when it comes to these guys, they have properties that are a little bit like both of those things. So we just sort of threw up our hands in frustration and said, you know what, we're going to make a third group. We'll call it the metalloids. Some people call it the semi-metals. I like metalloids. An example of these would be silicon. Silicon is element number 14, lives right here. Silicon is hard like a metal, but brittle like a nonmetal. Under certain conditions, it is a conductor, and like a metal would be, and in other conditions, it is a non-conductor, an insulator. That's what makes it useful for making computer chips. It is a metalloid. It has properties that are in between metals, or a blend of metal and non-metal properties. The nonmetals are all the elements to the right of the metalloids, including hydrogen, who hangs out over here on the other side of the table. Nonmetals are mostly gases and soft, crumbly solids. Let me just rattle off some of their names, like hydrogen, oxygen, nitrogen, helium, argon. These are mostly gases, you probably know. And then you have things like carbon, which is like a charcoal brick, or sulfur or phosphorus, like a match head, is a powdery, brittle, kind of chalky solid. Those are nonmetals. The metals lie to the left of the metalloids, and metals have classic properties of being solid at room temperature, shiny, solid, smooth, good conductors of heat and electricity. If we have a look at the periodic table, you're going to see there's 118 elements, and sometimes it's just too much. If we want to simplify the periodic table and look at a pattern, say, without having to see all of the 118 elements. Sometimes it's just difficult with so many elements. We can reduce the element down to what we call the main group, or sometimes we call these the representative elements. These elements have a wide range of properties. They represent the periodic table really well. We have some things that in the room right now would be solid, some would be liquids, some would be gases. We have some things that are very reactive and some things that are very unreactive. We have metals, nonmetals, metalloids. We have all kinds of properties. Kind of like our representatives that we elect represent us. They are, 50% men and 50% women. There is a wide range of creeds, colors, and races there. We have people who are very wealthy and people who are very poor, and mostly people who are in the middle. Wait, hang on. Our representatives are mostly just old, rich, white guys. The periodic table does a better job with its main group or its representative elements than humans do. The alkali metals are this group of metals, a subgroup of them way over on the left side, that group that's in the first family below hydrogen. These are famously reactive metals. For example, when you put most of them in water, they catch fire and some of them explode, or hopefully we'll be able to do this demonstration in class. This is a hunk of sodium being put into a bowl of water. They are the most reactive of all the metal elements. Their neighbors, the alkaline earth metals, are also quite reactive and are found abundantly in the Earth's crusts, things like magnesium and calcium and strontium. These are elements that are also metals that are quite reactive. Some people feel like calcium, they feel like it's in your bones and your teeth. It shouldn't be a metal. It is a metal. Your bones contain calcium, but they're not made out of calcium. That would be actually quite bad. The transition metals are the group in the middle, what we call the D block of the periodic table, and we call them the transition metals because their properties transition from being very metallic on the left. Think of ones on the left like titanium, which is like a metally metal. It has all of the classic metal properties and is a very classic metal. And as you move over to the right side of the table, we start to run into some weirdness. They're starting to transition their properties, like copper, which is a weird color for a metal, or mercury, which is a liquid metal. That's a super odd behavior. As we go to the right, it's almost like if we were to keep going to the right, eventually these aren't even going to be metals anymore. Their properties are getting a little fruity. And of course, that is going to be the case. On to the inner transition metals, that island of metals down on the bottom that nobody's quite sure why they're down there. It's not the island of misfit toys. It's not a prison. These aren't degenerates. It's not a leper colony. There's nothing wrong with them. In fact, they've been served a great injustice. When people decided that 8.5 by 11 sheets of paper were the best sheets of paper, this part of the periodic table was doomed to be cut out because the whole periodic table actually looks like this. Those bottom two rows are the green ones in this picture. They get stuck into that spot, and this makes it too hard to print a periodic table on a regular sheet of paper because the squares are too small and you can't get all the great stats and information in there and still be able to read it. So we decided to suck them out of there and make a group on the bottom. The last group of subgroup of metals is the representative metals. And these are the metals in between the transition metals and the metalloids. They are the representatives of the metals in the representative elements. Remember, the representative elements is that smaller group of 50 that we often talk about when we're looking at patterns. They just have got some metals with some, odd or fruitier properties, and so we include them so that the metals are well represented in all of their diversity. The noble gases are the first subgroup of nonmetals that we're going to talk about. The noble gases are famously unreactive. They won't react with anybody. That's why we call them noble. Not because they're like brave or honorable or chivalrous, but because they're entitled and kind of lazy and don't do anything. The noble gases don't do anything. In fact, when we use them, that's what we actually use them for. Like, for example, argon is used as a shielding gas in welding. If this was like a wire feed welder's nozzle and this is the wire feeding down in, we're melting two pieces of metal together. And while that metal is white, molten hot, the oxygen in the air would react with it and make rust, which makes the weld both weak and ugly. So we spray a shielding gas, normally argon, out of the head of the nozzle of the welder, and it blankets that white hot metal with unreactive gases so it can cool down just for a moment. And then the oxygen won't rust that metal immediately. That's what we use a noble gas for, to do nothing, to sit there and block everybody from doing anything. The neighbors are the halogens. The halogens are famously reactive nonmetals. Fluorine, in fact, might be the most reactive of all the metals on the periodic table. Chlorine was the first poison gas used in warfare. It was a mustard gas used in World War I. It's a green, poisonous gas that if you get a good lungful of it, you will barf out your lungs in bloody clots right in front of your eyes before you die. The halogens are very, very reactive nonmetals, the most reactive nonmetals. And that pretty much brings us to the end of this lesson on periodic table geography. Here's sort of the whole enchilada all in one place for you to get it colored down.